Hello everyone. Today we'll discuss exercise 7.2 question number 3. You are told that 1331 is a perfect cube. Can you guess without factorization what is its cube root? Similarly guess the cube roots of 4913, 12167, 32768. First of all, let us take the number 1331. First of all, take the number that is 1331. The number is 1331. 1, 3, 3, 1. Right? Divide this into two groups. In one group it is 331, another group it is 1. Right? Now take 331. Now take 331, 3, 3, 1. Right? Here you see the digit at its unit place is 1. Here you see the digit the digit at its unit place the digit at its unit place is 1. The digit at its unit place is 1. We know that. We know that. We know that if the digit 1, we know that if the digit we know that if the digit 1 is at the end of a perfect cube, is at the end of a perfect cube, at the end of a perfect cube, of a perfect cube, of a perfect cube, of a perfect cube, then its cube root, then its cube root, then its cube root, then its cube root, cube root, then its cube root will have 1 at its unit place, at its unit place, right? We therefore the unit place therefore the unit place of the digit, the unit place therefore the unit place therefore the unit place therefore the unit place therefore the unit place of the required cube root of the required cube root of the required cube root can be taken as 1, can be taken as 1. Now let us test the second group. The second group is 1. The second group second group is 1. The cube of 1, the cube of 1, 1 exactly matches the cube of 1 exactly matches with the second group, with the second group, the second group, right? With the second group. Therefore the tens, therefore you can take therefore the tens digit, therefore the tens digit, therefore the tens digit, therefore the therefore the tens digit, therefore the tens digit, therefore the tens digit, therefore the tens digit of our cube root, tens digit of our cube root, of our cube root, of our cube root, tens digit of our cube root, tens digit of our cube root will be taken, will be taken, will be taken, will be taken as the unit place, will be taken as unit place, as the will be taken as the will be taken as the will be taken will be taken will be taken as the therefore the tens digit of our cube root will be taken as the unit place, taken as the unit place of the smaller number, unit place of the smaller number, of the smaller of the smaller unit place of the smaller number whose cube is this, whose cube whose cube is near to the number, whose cube is near to the number, near to the number of the second group, of the second group, of the second group, right, of the second group. Therefore, 1 would be taken. 1 would be taken. Therefore, 1 will be taken as tens place of the cube root. As tens place. Tens place. Taken as tens place of the cube root of the cube root of the cube root of 1331 1331, right? There we can find that the cube root of 1331 is equal to 11, right? First I've already divided in two groups, that is 331 and 1. You see, in digit 331, the digit at its unit place is 1. We know that if the digit 1 is at the end of a perfect cube, then its cube root will have 1 at its unit place. Therefore, the unit place of the required cube root can be taken as 1. The second group is 1. The cube of 1 exactly matches with the second group. Therefore, the tens digit of our cube root will be taken as the unit place of the smaller number whose cube is nearer to the number of the second group. The 1 will be taken as tens place of the cube root of 1331. Therefore, 1 1, that is the answer. Now, similarly, guess the cube roots of 4913 and 12167, 32768. Let us find the second group. Now, the second number here you see is second number is 4913. Let us take 4913. 4 9 1 3. Divide it into two groups, that is 4 913. Divide into two groups. One is 913 913. Another group is 4. Divide these into groups 913 and 4. Now a unit place is 3. You see, unit place is 3, right? Since unit place is 3, then we can say that the digit 3 is there at the end of a perfect cube of a number, then its cube root will have its units place digit as 7, because 7 7 is 49 and 7 9 is 63. 3 is at the end, right? Therefore, you can take this digit as 7, right? Now here you see 3. We can write here. Take the first group. The first group is 913, and here also you see it is 4. It is 4. 4 lies between 1 cube and 2 cube. 1 cube is equal to 1, and 2 cube equal to 8. That is 4 lies between 1 and 8. Lies between 1 and 8. So you have to take the smaller number, that is 1. That the cube root of this is 1 and 7. Now we are explaining this one, right? We have to take the two groups, that is 913 and 4. First we are taking 913. The digit we know that here you can write here as we know that we know that we know that If the digit 3, if the digit 3, if the digit 3 is, if the digit 3 is at the end of a perfect cube, is at the end, is the end, at the end of a perfect cube, end of a perfect cube, end of a perfect cube, right? End of a perfect cube, then its cube root will have, then it, then its cube root will have its unit place, unit digit as 7. Then its cube root, then its cube root, then its cube root will have, will have, then its cube root will have its unit place digit, unit place digit, digit as 7, digit as 7. Because you know that 7 49, 14, 7, 7, 60, you see the last digit is 3, right? Now, here you take one cube, we have to take the smaller number of the cube, right? Now, if we take the first group, another one, that is 1 cube, 1 cube is equal to 1, and 2 cube is equal to 8. But you see that 1 cube, 4 is greater than 1 cube, but less than 2 cube. So we take the smaller number, that is 1, right? Therefore, 1 will be taken as the tens place of the required cube root. Therefore, 1 will be taken, 1 will be taken, 1 will be taken, the 1 will be taken as the, 1 will be taken at the tens place, taken at the tens place, 1 will be taken, 1 will be taken at the tens place, 1 will be taken at the tens place, at the tens place, at the tens place, 1 will be taken at the taken at the tens place of the required cube root, of the required cube root, of the required, of the required cube root. Therefore, we can write that cube root of 491349113 is equal to 1 7, and that is the answer. 1 and 7, and that is the answer, right? Now the next question is 12167. Let us take the next number. The next number is, here you see, is 12167. 1 2 1 6 7. We'll divide it into two groups, 1 6 7 and 12, right? Let us first take this group, 1 6 7, 1 6 7. Now 7 is at the unit place, 7 is at the unit place. Therefore, we can get the 7 only if its unit place digit is 3. Why? Because 3 is a 9. If we got 3 cube is equal to 3 cube equal to 27, and the last digit is 7. You see here, right? Then we can write here as we know that we know we know that we know that if the digit 7, if the digit if the digit if the digit 7 if the digit 7 is at the end of a perfect cube, is at the end is at the end of a perfect cube of a perfect cube of a perfect cube, there is cube root, then its cube root, then its cube root, then its cube root will have, then its cube root will have, then its cube root will have its unit place, its unit place digit, unit place digit, unit place digit, unit place digit as 3 only, as 3 only, right? Now the second group is 12. It is 12, right? Now we know that 12 is lies between 2 cube and 3 cube. 3 cube. 12 lies between 2 cube and 3 cube. 24, 48. It is 12. It is 27. Right? The smaller number is 2. Right? Therefore 2 is a smaller number between 2 and 3. 2 is a smaller number. 3 is greater. 2 cube lies between 12 lies between 2 cube and 3 cube. The smaller number is 2. Therefore, at the therefore therefore 2 will be taken as therefore 2 will be taken will be taken 2 will be taken as the tens place, taken at the tens place, at the tens place, at the tens place of the required cube root, of the required cube root, of the required cube root. Therefore, we can write that cube root of 12167 12167 is equal to 23. Right? Now I take another number, that is 32768. Let us take the another number, next number, that is 32768. The number is 32768. Now here we get two groups, this group and this group. Now first we'll find the tens place. The number is 32, and we know that 32 lies between 32. We know that 32 lies between 3 cube and 4 cube. 3 cube and 4 cube. Because 3 cube is 3 is 9, 3 is 27. That is 27 and 32. And 4 cube is 4 4 is 16. 16 into 4, that is 64. The smaller number is 3. Therefore, at the tens place, it will be 3. At the tens place of the required cube root will be 3 because it is a smaller number. That is 3. And here you see 768. 768. This digit 8 is the end of a number. Right? 8 is the end of a number. 8. We know that. If you take the cube root of 2, then it's 2 to the 4, 4 to the 8. 4 to the 8. Right? Therefore, we can say that 768, here you see 768 ends with 8. Ends with 8. Ends with 8. Therefore, we know that. We know that if the digit is at if the digit 8 if the digit 8 if the digit 8 is at the end of a perfect cube is at the end at the end of a perfect cube at the end of a perfect cube then its cube root then its cube root then its cube root will have then its cube root will have its units place digit its units place digit unit place digit unit place digit as 2 only right. And here you see 32 is between 3 cube and 4 cube. The smaller number is 3. Therefore three will be taken. Therefore 3 will be taken. 3 will be taken at the tens place. 3 will be taken at the tens place. At the tens place of the required tens place of the required cube root of the required cube root required cube root. Therefore, you can say that cube root of this number, cube root of 3 2 7 6 8 is equal to 2 required as we wrote this number required as 3. Unit place is 3. Tens place is 3. And unit place as 2. That is 32. Right? Dear friends, if you like this video, please subscribe, like and share, and also press the notification bell so that you may get the uploaded videos immediately. Thank you everybody for watching this video.